Hi, everyone. Thanks for tuning in and welcome to our showcase session. I hope everyone is safe and doing pretty well. Today, we are going to talk about a non-functional testing platform for a change. Let's shift our focus from functional to security testing. I think we have showcased several functional testing platforms in the forum so far. We are going to talk about a security testing platform, and I'm sure it would be a great learning for everyone from this session. When it comes to security testing, two types of testing generally comes to our mind, SAST and DAST. SAST is basically the static application security testing that needs access to the source code. We also call it a white box based security testing. And at the other hand, we have DAST, or dynamic application security testing, that doesn't need access to the source code, and we generally call it black box testing. So in the showcase today, we have a powerful DAST based application security platform called Deepfactor. And we have Kiran and Dinesh from Deepfactor who will take us through their journey so far, the product capabilities, how to get started, a quick demo as well. I'm sure you are going to like the session. Please watch this session until the end. With that, let's get started. Hey, Kiran, thanks for joining. It's an absolute honor to have you on this meeting today, Kiran and Dinesh. Kiran, before we start, would you like to give a quick intro about yourself and tell us a little bit about your responsibilities at Deepfactor?
Yes. Hi, guys. Kiran Kamity. I'm the founder and CEO of Deepfactor.
Thank you, Kiran. Dinesh, would you like to give a quick intro about yourself?
Sure. Hi, guys. My name is Dinesh, and I head up our customer experience or customer excellence team here at Deepfactor. So I work with all technical aspects of our product.
Thank you so much, Dinesh and Kiran. So going back to Kiran. So Kiran, today's discussion is more focused around security testing. And we have so many followers who are checking about what's happening latest in the industry from security testing standpoint. So would you like to tell us a little bit about your journey in this industry and what was the motive behind Deepfactor, and take us through a little bit of your history or journey so far?
Yeah, absolutely. One of the biggest trends that is happening right now is enabling QA as well as developers to identify security issues early on during the course of development and testing so that you end up shipping a secure application. And there are up and coming tools and platforms like Deepfactor that are emerging to make that happen. Prior to Deepfactor, just to give you a bit of my background and what kind of made me think about this concept, I had sold my previous company, ContainerX, into Cisco a few years ago. At that point, I ended up at Cisco's cloud business unit. I was the head of product for Cisco's cloud business unit, responsible for OpenStack, container networking, and a few other teams and initiatives. As I was watching this whole space evolve, the cloud native development space, almost from day one of the Docker, evolution, it's been fascinating to see how people have shifted to building cloud native applications so fast over the course of the last 7-8 years or so, that in fact, Gartner predicts that 95% of new application development is going to happen using Docker and Kubernetes and cloud native fundamentals by 2025. At the same time, we're seeing engineering organizations, dev and QA included, grow tremendously. Like today, that number is, the total number of developers and QA engineers in the world is about 26 million people worldwide. And that number is supposed to get to about 45 million by 2030. Come to think of the magnitude of this, as an industry, we're basically going to be adding almost as many dev and QA over the next decade as we have added in the last 4 decades put together. That's crazy. So lots of people writing lots of code, creating lots of new cloud native applications. And thanks to DevOps, etc., these apps are being shipped at a very rapid pace. What that means is your security risks are also shipping at a very rapid pace if you don't do something about it. So you need tools that identify these risks early on in the dev as well as test pipelines, both manual testing, automated testing as well, so that you end up identifying as many security risks as possible early on, and you don't end up getting hacked, or you significantly reduce the chances of getting hacked when your application gets widely deployed in production in the future. That, in a nutshell, is what led me to start Deepfactor. And Deepfactor is a developer security platform, and we're here to tell you all about it. And Dinesh has an awesome demo that he'll show you as well. We've created something that is very powerful, that without requiring a single line of code change to your application, enables dev teams, as well as gives the power to the QA teams to be able to simply run a simple command or drop it into Kubernetes in their test environments, both manual and automated, and identify the risks that exist in their application in one simple integrated solution. Hopefully that gives you an idea of the vision and what led me to start this.
Absolutely. And as you know, in DevOps, people generally talk about shift left and things like that to get started on the functional or non-functional testing much early in the life cycle. So how do you see Deepfactor helping on shift left perspective?
Yeah, I mean, in fact, we're not just shifting left, we're really starting from left. So what we enable is for organizations, especially QA teams, to not just have visibility into functional testing and performance testing, which is what most of the QA teams focus on today, but truly provide that third pillar of security testing, enable that as part of their capabilities. Imagine the power of, if QA teams had the right tools, they'd be able to go and say, hey, not only that, hey, when I click this button, this thing doesn't happen, or your application is taking too many CPU cycles or whatever, but they should also be able to file bugs around. I noticed that in version 1.x of this microservice, log4j is still present. And I noticed that your developer brought in some piece of code in last night's spill that is making an outbound connection to Malaysia to do something. Imagine if QA teams start filing bugs like that, as opposed to waiting for the security teams or the AppSec teams to come in at the end of the release. That will help you create a culture in engineering which is security driven, and therefore, create a more secure product, make it a habit.
Absolutely. That can be kind of, built into your culture of DevOps, right? So yeah, I understand what you were saying. So coming back to, again, Deepfactor's, journey, would you like to tell us about your company a little bit? Where are you guys operating from? And tell us a little bit more about Deepfactor as a company. I think that would be very interesting to listen from you.
Yeah, awesome. So we are a roughly 3-year-old company. We are Series A stage. We've raised in total a little less than $20 million so far. And we are, somewhere between 30 and 35 right now. And our we have 12 open recs as well. So we're looking to hire people in both India as well as the US. I understand your audience, Try, is majority in India. So we have offices in both Bangalore and Pune in India. We're looking for Golang programmers, C++ programmers, QA engineers, performance testing engineers, and as well as security people. So please check out deepfactor.io for the jobs page and do apply. In addition, obviously our headquarters is in Silicon Valley, San Jose. That's where I'm based out of. But because we are a COVID first company, we took the approach of a fully remote style work. In fact, we had leased a small office in San Jose that right after COVID hit, we decided that's not the right model for us. So we just end up completely closing the office and opening up our hiring across the US. So we now have in the US, we're fully distributed. Even in India, while the focus is in Bangalore and Pune, we're open to hiring people from other places. And we have some employees that do work from other places as well. So that's kind of, in a nutshell, the journey of the company from a logistical perspective. And from a product perspective, we launched the product late last year, and we're seeing increased customer momentum, and we have huge plans for growth this year as well as the next year.
Very nice, and all the best wishes for your hiring process. Coming back to Deepfactor, would you like to take us through, your product profile or anything that you would like to share in the forum today?
Yes, absolutely. I'd like to share a few slides. Maybe that's the best way to explain the concept. And Dinesh can share his screen and present the demonstration as well.
Sure.
Let's So the plan is to walk through a few slides to give an overview of the Deepfactor platform. To summarize again, Deepfactor is a developer security platform. And we use the word developer in an all-encompassing way that includes both devs and QA engineers. The goal for Deepfactor is to empower engineering teams to create secure applications by identifying the risks in their applications during dev, during QA. Especially for the QA audience in this group, this is a perfect tool because it observes your running applications and identifies risks. So you don't have to do anything with your code. You can just simply run the builds that have been created, which is much better suited for testing kind of model. Let's dig in. We've already done introductions with Dinesh and I. So I'm going to skip this slide and jump into what is developer security. There are an up-and-coming group of tools that we are seeing these days. Deepfactor is definitely one of the pioneers in that space that enables engineering team to create a culture of security both in dev and QA and make shipping secure releases a practice, a habit. That in a nutshell is what developer security, a good developer security tool is supposed to give you. Number one, create that security culture. Security should not be something that you leave it till the end of the release. It is something that you want to bake in during the course of your dev and tests so that your engineering teams detect risks and get into the habit of QA teams filing security bugs. And that is all resolved during the course of development as opposed to waiting till your final release candidate kind of goes out. At the same time, culture of security creation usually comes with two things, knowledge and the tooling. The knowledge, it's important for a good developer security tool or practice to tell the developers when they do something that could be risky. For example, if a developer writes a piece of code that has got some security risks in them, or if a developer brings in a third-party library or puts something in their container image that has got some risks or vulnerabilities in them, telling them at the time that they did it, the very same day or the next day, by observing their application during their nightly regression tests and telling them, hey, you wrote this piece of code. That piece of code has this potential risk because it was reaching out to Malaysia to do some bad behaviors that you may not have anticipated, is a great thing for the QA team to go file a ticket for. And that just-in-time education we find is a lot more useful and powerful than sending your engineers to a 2-day security training course, because that's not going to be as contextual. It's going to be far more generic. Number three is you get in the habit of shipping secure and compliant applications by default. I think a good tool has to do that. And in order for that to do that, you shouldn't need like 5 or 6 different tools, which totally makes sense for AppSec teams to have because they have the skill set to tie together this many tools. But from an engineering team perspective, it should be a very simple tool. It just should drop into your existing flows, your dev and test workflows, and tell you that these are all the comprehensive risks around. But instead of overwhelming your developers and QA teams, it should try to prioritize which ones kind of make sense, because the one last thing you want from these tools is so many alerts that your devs get overwhelmed by it. And stop using it altogether. We've seen, and that term is called alert fatigue. And that basically results in engineering teams just turning off these tools. So at Deepfactor, we've taken all of these fundamentals into account, and we've created, our mission is to create the best developer security tool possible. What we do
quick question here, Kiran.
Yes.
You said, both developers and QA teams can use Deepfactor. So are they going to test the same type of test scenarios, or you recommend different scenarios for developers and different scenarios for QA people?
I think the QA tests are probably going to be a bit more comprehensive, because the way Deepfactor can be used is Deepfactor primarily fits into, when you create your container image, or when you're testing your application in a test Kubernetes cluster. That's where Deepfactor is going to be listening to your application. So you can do it in your dev environment, in which case the developers may not exhaustively run the application through a bunch of test cases. They'll still find a bunch of low-hanging fruit issues very quickly. QA teams can then run it with, just turn it on during their manual testing. So all the work that they're doing as part of their regular testing magically converts into security tests, because Deepfactor is observing your application and tells you that these are the security risks I found while you were testing your application. And then the best way to kind of automate this is to turn it on in your test, regression testing environments. As you're running your nightly regression test, you just simply flip the bits and turn on Deepfactor. Then you get not only the findings while your automated tests are running on your application, you also get to compare which release behaved which way and which vulnerabilities were introduced in what nightly builds.
Got it.
Which is which is useful for QA teams to file bugs against.
Yep. And that would also reduce the time taken to, address the issues, right? Found by the QA team, right?
Yeah.
Because all the most of the defects are already detected by the developers. And when it comes to the QA for the full regression testing, I think the chances are that they will find less number of bugs, and that would reduce the time it is required to fix those defects and bring the release ready for production. That makes sense.
Absolutely. You'll find less number of bugs. You'll also find these bugs early on in the release cycle, so you don't have to wait till the release candidate. You're finding it on your nightly builds every day.
Got it. Yep.
Awesome. So, in a nutshell, to introduce Deepfactor is one of the pioneers in the area of creating a developer security platform. Our focus really is in cloud native applications. However, we do work with traditional monolithic applications as well. But when it comes to Kubernetes or Docker-based applications, we really shine. There are a few unique things about Deepfactor that enable or empower engineering teams to create secure and compliant applications with as little friction as possible. Number one is how seamlessly Deepfactor drops into your cloud native applications. So you have a few options. You can turn Deepfactor on at your, when you're observing your container. We simply have a CLI. You say dfctl run your container image, and Deepfactor identifies the risks in the container image by watching it run. It both examines the static container image as well as the running container image. With Kubernetes, we have a pretty awesome webhook. All you do is helm install the webhook, and then Deepfactor drops into your Kubernetes cluster, the test cluster where you're running your nightly regression tests. And there you can specify with an override YAML file the namespaces that you want watched by Deepfactor. And anytime any container or pod comes up in that namespace, Deepfactor looks at every thread, every process running in every container and pod. And it observes more than 200 types of parameters inside each of these processes, including how is your container, the process that is running in your container, how is that doing memory allocations or network behaviors or file system behaviors, so on and so forth. It then takes all of that rich telemetry, sends it to the Deepfactor portal, and the Deepfactor portal detects the anomalies and tells you these are the security risks that exist. And anytime Deepfactor finds that there is a certain risk, it goes deep into the application because it's observing so many things about what's happening inside the process. It's able to tell you, here's the risk, and whenever possible or applicable, it tells you, here's the stack trace. Or if it's a vulnerability, for example, log4j, it tells you, here's a container that has log4j, and it goes much beyond that and tells you whether log4j is used by that container, and if so, which methods and classes were used. Because sometimes you see that a lot of the times there's vulnerabilities that may exist in your application, but it only matters to you if your application is vulnerable or not whether a vulnerability exists or not. And that determination can be done based on whether the vulnerability is used by your application. So we call them application-aware insights, deep insights that provide actionable remediation guidance to developers and QA teams, so they know how to fix the problem. And lastly, we've taken the approach of a unified developer security platform. So there are several layers of risk that exist in every container or cloud native application. And our goal is to provide a good surface area of coverage so that you can detect a lot of these risks without having to put together 5-6 different tools, because engineering teams don't have the time or the security skill sets in the team to string together 5 different tools and all of that. So, we wanted to provide a more unified kind of solution. There are some customers that use Deepfactor purely by itself in the engineering team and let AppSec teams use their own tools. There are some customers that use Deepfactor as their primary security tool. There are some customers that use Deepfactor alongside other tools like code scanners or like software composition analysis tools. In fact, we recently announced a partnership with Black Duck. So if you have Black Duck as a software composition analysis tool of choice, then Deepfactor can nicely do a one-click integration with Black Duck, vulnerability database itself. So there's different ways in which you can use the product, either standalone or in conjunction with the other tools that you have. So there's flexibility. Let me jump in a little bit deeper, and we'll go through this is actually a very interesting slide. In fact, if there's any one slide that your team will probably take away, it's probably going to be this slide. It's an example of a microservices application and the risks that exist in microservices application. If from the perspective of what is an anatomy of a cloud native application, where do the risks lie? Here is a 3 microservice application. Front end, my service, and database are the 3 containers that you have. In every microservice, every container image, there are typically 4 areas of security risk and 2 aspects of compliance that engineering teams, most engineering teams, need to be worried about. One is application code, the code that your developers write. Number 2 is the dependencies that they use. For example, if you have a jar file, the things that get packaged up into the jar file. Number 3 is the container images themselves, all of the RPMs and packages that you put in the container image that makes up the totality of your image. Number 4 is the applications may have. Security risks can lie in all of these 4 areas, and I'll give you a few examples of that. In addition, there's a couple of compliance aspects. One is, if depending on your product, is it, sometimes PCI DSS might be important. Sometimes, SOC 2 Type 2 might be important. But identifying how these security risks kind of map to compliance, for example, and being able to say, hey, out of the 50 security risks that I have, 20 of them might affect PCI DSS. Knowing them during the course of development is so much more helpful, because when you go for your compliance auditor, you're already much better prepared, at least from the application side. And the other aspect that has become more and more important lately, especially if you're selling into defense, is Joe Biden's executive order came up last year. And it's important for you to get a handle of your full bill of materials so that you can stay on top of supply chain attacks. And this was evident with SolarWinds and attacks like that, that basically means that you need good tools that understand the composition of your application and what makes up the total bill of materials. And we do some really innovative things there, because we not only tell you static bill of materials, but also dynamic bill of materials. I'll tell you about that in this next slide. So just to give you an example of the types of things that exist in each of these areas, the risks, the examples of the types of risks that could exist in your code or dependencies could be that your developer left secrets in your environment variables. For example, they left some Postgres password is left in clear text as an environment. That's we notice that in things like that in some customer cases. Customer wrote, your developer wrote a piece of code. For example, a C developer wrote stir copy instead of a stir end copy. So they didn't do a bounce check. So your application could be susceptible to buffer overflow. Or you have a process that is running as root, privilege escalation possibility. Or you're not using some cryptography keys right. Or the example that I gave before, which is your developer brought in dependency, and that dependency is making an outbound connection to a certain geography that you did not like, for example, Malaysia or Madagascar, and you weren't expecting that. Issues like that can be caught, and if they're caught in QA itself, that is so much more powerful, because you end up shipping a far more secure application right from the get-go. Number 2 is supply chain, identifying the risks and vulnerabilities that exist in your dependencies and your container images. So do you have CVEs such as Spring4Shell or Log4j, or do you have any other vulnerabilities? Licensing information is a very common thing. Has your developer brought in a third-party dependency, and unknowingly that dependency is a GPL licensed product? That has ramifications from a legal perspective, that you may have to end up open sourcing modules of your code if you don't pay attention to whether GPL is being shipped with your product. So keeping a watch on that in an automatic fashion. I mean, imagine the power of if a QA member were to go and say, hey, the code that you checked in, Mr. Developer, last night, that has GPL. And knowing that the same day or the next day morning is so much more powerful, because then the engineering team has plenty of time to plan and use a different component if required. Deepfactor goes a step beyond that, as Dinesh will show you. We also show you usage information. We don't just tell you there is Log4j, we tell you whether Log4j was used by your application, if so, which functions and methods. For web and API interfaces, scanning the interfaces is important for OWASP top 10 standards, so SQL injection, cross-site scripting, so that functionality is baked in as well. like I said, for bill of materials, our goal is to provide not just the static list of components, but go beyond that, because we observe the running containers, not just the static container artifact. We're able to tell you that dynamic things like which ports did your application open, or which processes did it spawn, or what outbound connections did your dependencies make. And knowing that both on an absolute level as well as from a comparison point of, hey, release 1 didn't do it, but release 1.1 started listening in 1 extra port. Is that legit? I mean, if you want, or did that just slip through? Understanding things like that is, helps you get a handle on supply chain issues better. And of course, mapping all of these risks into the compliance frameworks that I mentioned. So this, in a nutshell, is kind of the totality of the insights that Deepfactor covers. And we've been frantically adding more and more insights over time. So this is a very comprehensive product, at this time. Any questions, Try?
So one question that I wanted to ask here, Kiran, is you said you do not need the application code, and I can see some bunch of risks that you have highlighted. So is it related to code, or we can test that from outside the application?
Yeah, that's the magic. That's the IP that we've created. In fact, we filed several patents in this area where, without getting access to code, we're able to identify all of these things. We get we point you down to the stack trace itself, and especially for issues like this on the left, because we look in the jar file, get the symbols, and we observe the running containers, find the issues, and then we map the symbols, and then we show you this is the issue, and here's the stack trace, here's the line of code where it could have happened. And all of this is done magically at runtime without actually even pointing to your Git source.
Got it. And can you speak a little bit about the customizability of your product? Can we customize that to the OWASP other beyond the top 10 kind of vulnerabilities also?
Yes, we have an extremely exhaustive policy set, so you can go customize your policies. In fact, majority of the customers just pick the default policy that we have. However, Dinesh and his team helps the customers with identifying and fine-tuning policies so that we increase the signal and reduce the noise. Our goal at the end of the day is to not just tell you all of, give you a comprehensive kind of MRI of your application, so to speak, but we also want to tell you less number of things. We don't want to keep frightening you all the time. So our goal is to make sure that the signal to noise ratio is really high.
Great. This slide actually tells the capabilities very nicely about Deepfactor, and looks like great coverage, Kiran. It looks really great.
Thank you, Frank.
Yeah.
Awesome. So, but successful DevSecops is not just about tooling. So picking the right developer security solution has to go beyond tooling and do things like prioritization. And this is where observing static container image and correlating it with a running container behavior helps you prioritize, like the log4j usage example that I gave, right? It goes beyond that into educating developers. So when these issues are found, sending a message into your Slack channel to tell the developers that, hey, that particular build has this issue, or and also providing that whole unified kind of experience that goes beyond just the tools, but tooling, prioritization, developer education, everything put together in a simple integrated solution is essentially what Deepfactor kind of provides for you. That's why it's a grand vision, and we've created a comprehensive developer security solution.
Kiran, that was a great story. Thank you so much.
Thank you, Chai.
Yeah, I think when it comes to security testing, most people talk about the OWASP top 10, but for the first time, I'm seeing something beyond OWASP. So I think that is a message that we can probably give to the community, that there are certain other things that we can expect as part of compliance and at the code level, without even having access to code, the code related security issues and so on. So very nice story. Thank you, Kiran.
Thank you. So with that, let me pass it on to Dinesh. Dinesh, if you can go through the slide and a demo, that would be great.
All right.
That'd be great. Thanks, Kiran. Great. Okay, so what I'll do is maybe I just want to spend 2 minutes covering the developer experience. So Kiran mentioned how it's very easy for developers and QA to kind of collect all this telemetry and analyze the data. So I'll walk you through the developer experience. So I think everybody is familiar with the DevOps process here. So as a developer, you would do one quick, simple thing. So there's no instrumentation to code as Kiran required. There's just a simple webhook that gets deployed into a Kubernetes cluster. So here, for example, it's a Helm command. You specify some parameters in the override file. And here you can specify things like which pods you want to monitor, which namespaces. It's very customizable. Again, this is just an example of monitoring in Kubernetes, but there's also the flexibility for the developer to run this locally. So if you think of a developer's experience or a journey, they finish up the code that they're working on, they push it to some type of repository. There's a CI job that goes ahead and builds and deploys their application. So as that application gets deployed and the developer is testing his or her feature, bug fix, whatever the case may be, Deepfactor starts collecting all that telemetry. And then in real time analyzes it for all those various components that Kiran covered, right? So everything from application risk, supply chain, vulnerabilities, OWASP, and compliance. And then that feedback is provided directly back to the developer. So if you don't want to run it locally in your local environment, the next stage is you can potentially just run it in the staging or test cluster. So another opportunity or another point which Deepfactor can be integrated. So again, the same rules apply here. So as the QA team is exercising their application, they're leveraging those test cases that they've already created for the QA testing, which means that the application is collecting all that telemetry and the data is then being analyzed on the back end. From here, we understand that developers like to consume notifications in a variety of different messages, right? So we support lots of different integrations. Here, I've got a couple of examples. So for example, anytime a new alert is generated, they can be notified through Slack. Maybe you're a manager or you prefer to look into a UI, you can sign into our portal, which I'll walk you through here in a few seconds, and review the findings. Or if you just simply want to say, hey, anything that is greater than a P1, just automatically take the contents of that vulnerability and open up a Jira ticket. And then you repeat that process, right? So again, as Kiran mentioned earlier, the goal here is really not to shift left, but to start all the way left. So from the time that the developer pushes the code into a repository, they're continually getting feedback to remediate and increase the security posture of their application. So with that, what I will do is I will jump in to the demo. So let me stop sharing this and share my entire screen. So hopefully, Kiran, can you see my entire screen here?
Yeah.
Okay, perfect. So what I'll do is I want to give you a quick example of actually how easy it is to deploy Deepfactor. So I mentioned earlier that you just simply deploy this webhook. So here, if you take a look at my Kubernetes cluster, you can see that I've deployed the webhook, and that was that single Helm command to get that up and running. And what I'm going to do is I'm going to actually go ahead and deploy an application into this production namespace. But before I do that, let me sign into the portal and show you what we see here. So the way that Deepfactor organizes the application is quite flexible. So I've chosen to organize my applications by name. So I've got 4 applications. I've got some C applications, some Java applications. And again, we understand that with microservice-driven architectures, several components are what make up an application. So here you can see an example of Bank of Anthos. It's running currently in my development namespace, and it has 6 components that are registered. Now, what I'll do is I'll actually deploy another copy of this Bank of Anthos. And I'll deploy it into the production namespace this time, just to show you what the experience would look like from a developer's perspective. So if I head back over to my shell here, you can see I've just got all my manifests. These are not modified. There's nothing specific about Deepfactor in these. These are just the manifests that the developer or the DevOps team would have created. And I'm just simply going to apply those into the production namespace. So if I go ahead and deploy those into the production namespace, you see that they start getting created. And if we go back and look at the cluster, you can see that those containers have now started registering into the cluster. And if I head back into our dashboard and just do a quick refresh, you'll see that it's automatically registered that new copy of Bank of Anthos in the production namespace. So again, here I manually kind of simulated a CI pipeline, but this would typically be a job, maybe whether that's in Jenkins, Circle CI, GitLab, something like that, that automatically deploys this application. So that shows you how easy it is to get up and running with Deepfactor. So now what I'm going to do is walk you through our application a little bit. So I'll make this a little bit bigger. So here you can see, as I mentioned earlier, everything is organized by application. And then from here, you can continually drill down to understand the security posture of this application. So I'll take a look at the previously deployed Bank of Anthos application here. And if I expand it, you start to get some more information. So here we can see that we've identified 130 security alerts. And how were those alerts distributed across the components Kiran covered earlier? So we can see that 15 alerts were in the runtime space, 103 were in the dependencies. We identified 12 vulnerabilities in the OS package. And in this particular case, I haven't run a scan yet. So there's no web or API alerts. But if I expand another one of these, you'll see that where I run a scan. So for example, on this interpreted languages, I've run a web scan, and you can see that is 15 vulnerabilities detected. So from here, you can also get a quick snapshot on how those security alerts map to compliance. So as Kiran mentioned, we're very specific to the application itself. So here you can see 92 compliance alerts against PCI DSS, 15 against SOC 2 Type 2, 86 against NIST. Now, these are very specific to the application. So typically when folks think about compliance, they're looking at the infrastructure from the outside in. Here, we've actually mapped all these application-specific alerts to potential violations in the compliance framework. And then we give you a quick snapshot of what that bill of materials or what components make up this application. So the number of dependencies, OS packages, et cetera. So from here, we can actually take a very close look at that entire application. So when I click on the dashboard, I now see all the alerts that have been generated across the various components. So earlier I mentioned there were 15 runtime alerts. Those were actually further broken down into file system, process, and node. We've done the same for dependencies. Obviously, we understand that in a microservice-driven architecture, the programming language may be different for each of the components. So here in this particular example, I've actually got the Bank of Anthos application, and it's built of both Java and Python. And you can see that there's a total of 256 dependencies and how those are distributed. But if you notice, there's 24 vulnerable dependencies, which generated 24 alerts. And we do the same for the operating system package. So earlier, Kiran mentioned usage-based alerts to avoid alert fatigue. So if you take a look at the OS packages, we can see that there's over 1,000 packages that make up this application, of which 232 are actually vulnerable, but we've only used 30 of those packages. And out of the used packages, 12 of those have generated alerts. So if you think of traditional or legacy solutions, they'll actually give you 232 alerts, which is quite overwhelming from a developer's perspective. We'll just give you the 12 tied to what's being used by the application, and then you can go back and remediate the other vulnerable packages as you see fit. Down in the center here, we can see we've provided some additional information around the software bill of materials. So we've broken down the types of languages that make up this application, how many dependencies, how many operating system packages. But as Kiran mentioned, we're also a dynamic bill of materials. So we understand things like the network, right? So how many listening ports have been created by this application? How many web services does it expose? And then we also have our web results here, or rather web and API scan results here on the left. So from here, I'm going to drill into a couple of these components just to give you some examples. So if we take a look at runtime, these are events that really only Deepfactor can identify when the application is running. So we've seen here that there's 15 alerts that are generated across several components. So here you can see the components, the title of the alert, the category that they belong to, and how many occurrences of this have actually happened. So here, for example, if I click on this process running as root detected in the user service component, it'll open up the alert and it'll give us a very rich contextual set of information about this alert. Now, in this case, it's quite simple because it's just a process that's running as root, but we tell you where it existed, which component, which application, the category that it was mapped to, and then if it potentially violates any compliance, give you a detailed description of what this means. But more importantly, from a developer perspective or a DevOps perspective, what the resolution is, how would you remediate this? And then we show you what was actually identified. So here we can see the processes, the process IDs, the time that it was observed. And I'll give you another couple of examples in a second here where we actually dive into some of the programming language specific alerts. But if I go back into the Bank of Anthos, there's one other alert that I would like to quickly show you. Kiran touched on this earlier, but we often find lots of environment variables that specify secrets. So in this case, you can see that we've identified that this particular ledger writer component has actually set a bunch of sensitive information as environment variables. So things like the data source password, the Postgres password. We've also seen things like the AWS S3 bucket keys. So again, this is very important that you remediate and protect these secrets in a vault rather than exposing them. And this is an alert that we see quite often. So with that said, let's go back over. So even though there's only 15 alerts that have been generated for this particular application, we actually compare this or monitor for a lot of other rules in the policy. So here we can see the types of checks that we've gone against, right? So everything from things like outbound connections that this particular application may be making, any types of suspicious paths that the application is executing from, any types of sensitive files that this application could be reading. So you can see here it's quite comprehensive. And on the right here, you see the green check mark, which means that it actually passed this, which means it's not doing that behavior. And you can scroll through here, you see lots of different policies that we map against. And then if you wanted to take a look at this at an individual component level, so as I mentioned earlier, this application is made up of 6 components. You can actually click on the components and get a breakdown across each of the components. Now, yes, go ahead.
I like that dashboard actually, Dinesh. I think at a high level, we would like to understand what are our P1s, how many are defects are P1s, P2s, and so on. So coming to the integration capability of this platform with other tools in the ecosystem, I'm coming from tracking the defects perspective. So where I can keep my defects, like for every build, I need to have the defect information, the metrics basically, right? So how does it fit with the other tools in the ecosystem?
Yeah, so we have a bunch of integrations out of the box today, right? So we can certainly create tickets and things like Jira and Jira Cloud. But in terms of tracking the evolution of that security posture of the application, we're actually introducing a feature called drift analysis. So if I go back into the application, today we can actually do that. And by default, this dashboard shows you the latest version of the component. But what we also track is historical versions of this component, right? So from a defect tracking perspective, you could, track or compare against previous versions, because we understand that depending on the type of environment, you could be pushing applications several times a day, and you want to track how that improvement, or if you've actually fallen back in security across those various builds. So today you would have to go in here and actually track based on selecting the version. But in an upcoming release, we're actually going to give a feature that says drift analysis, which allows you to compare against historical versions of that application. But Troy, does that answer your question?
Absolutely. And if some application teams have already invested in tools like Micro Focus ALM or some test management tool, where they kind of track their requirements and defects, test cases, and all that stuff. So does it expose some kind of API to talk to those kind of platforms?
Yeah, that's another great question. So everything that I'm showing you in the dashboard, we have an API for. So you can send all this information and you can group it, or you can do it down to the individual alert, or you can send all the telemetry information. But we have a very well-documented API that allows you to integrate into any third-party solution. So we've got a lot of folks that may want to take the alerts and send them into something like Splunk, for example. But again, it could be any third-party integration that supports API.
Very nice.
Yeah. In fact, the one thing I'd like to add there, guys, is when you mentioned the ALM product Micro Focus. So if you're running a tool like that, or Testim or Tricentis, or tools like that to automate your test cases, then the best way to kind of leverage Deepfactor there is turn on Deepfactor in the test environment, in the test Kubernetes cluster, or if it's not Kubernetes, in the test environment in general. And then turn on your, as part of your nightly regression test, let your Tricentis or your Micro Focus ALM test kind of run through all of your test cases. And Deepfactor will just be a fly in the wall. It'll watch your application. And at the end of your test cases, you stop your automation test, and then you query using the API that Dinesh showed. And Deepfactor will give you all the list of security things that it found by observing your applications as the automation tests were running against them.
Got it. Very nice.
Great. I just have a couple of quick items. I won't dive into too much detail in the interest of time. Just like the runtime, the alerts for the other components are very similar in the way that they're displayed here. So here we can see all the dependencies that made up this application. So on this particular view, you can see all the vulnerable dependencies that were imported into the application. We can see which those dependencies are. So here you can see that these components have imported a vulnerable version of Log4j. You can see what the CVSS version 3 or version 2 score is. And then we actually provide you with lots of detailed information about this as well, right? So we can point you to any additional references for you to be able to read some more about this particular vulnerability. We also track usage. So if you were to actually take a look at a tree view here, you can see, for example, the methods and the classes, and you can see where the particular vulnerabilities exist. And then in the interest of time, I'll just quickly show you the operating system packages. So we do the very similar thing that you could see before. So, which OS packages were actually vulnerable. You can see here that it's actually fixed in this particular version. You can actually see what libraries were loaded as part of the application. So there's lots of detail that make up these alerts. So just to kind of, double click on what Kiran mentioned earlier, all this telemetry is fed in to generate a very comprehensive set of alerts to give you, actionable alerts based on usage of the application. And then finally, you want to take a look at all the bill of materials or all the items that make up this application. So across the top here, you can see in the bill of materials, we have all the dependencies, all the operating system packages, what ports my application is listening on, outbound connections, etc. And then the other quick thing that I will show you is, I think there was a question, Tri, that you asked about, is it just vulnerabilities within the components or environment variables, or do we get down into the actual application itself? So in this particular C application, I just want to quickly point out this, application coding alert that we caught. So we can see that we triggered an alert that said a deterministic random number generation API was used. So in this case, it's actually something that exists within the code that the application developer controls. So in this case, it's a C application. We give you a detailed description, and then we give you that resolution, right? So how would you fix this as a developer, which is important, right, to educate the developer. And then here is that stack trace. So without actually doing anything to the application, just by observing it from the inside out, we're able to tell the developer that, hey, this particular vulnerability exists within this service. So in this case, HTTP service.c on line 31. And then the other quick final thing I wanted to point out is from the DAST perspective, right? So if I go back into the application that I ran a DAST scan on, we'll see that a bunch of alerts were generated. And again, I won't spend too much time here, but you can see things like, the OWASP top 10 that we've identified, things like X-frame option headers not being set, user agent buzzer, etc. So there's a lot more to the product, Tri. I certainly would welcome folks to schedule some time to dive deeper into a more detailed demonstration with Deepfactor. But with that, I'll turn it back over to you.
Thank you very much, Dinesh. That was a great demo. I really appreciate it. So OWASP, from time to time, the top 10 issues, they're dynamic in nature, right? They keep on revising those things. So how do you customize, Deepfactor to stay up to date?
Yeah, so there's a bunch of different ways, right? And I'll let Kiran maybe add on to my comments here, but we have automated jobs that update the rules on an every 4-hour basis, and then we also do component updates with our releases. So we're continually making sure that we're pushing down the latest rule sets to the platform.
Got it. I have 2 more questions. One is related to the services that you provide on top of this platform. So are you providing the professional services to build solutions on top of Deepfactor?
Yeah. I mean, today with our customers, when they install the product, the common ways in which they use some of our professional services is to fine tune the list of alerts or to help them set up the portal in their environment or their cloud tied to their load balancers and things like that. So yeah, basically our goal is to make sure the customer is successfully deployed. So we will provide help to make that happen.
Okay. And my last question is around the subscription. So is it like, if we have any questions around trial licenses or something like that? What would be the process, Kiran, you recommend?
Yeah, I mean, we're a fast-growing startup, so just reach out to us, and the details are here. In this slide, you can also go to deepfactor.io. Just contact us. One of our representatives from Dinesh's team is going to reach out to you. We'll set up a time with you. Do a demonstration if required with your team members, and you're going to get some POV licenses to try the product yourself prior to deciding whether you'd like to purchase. There's a couple of things I wanted to point out in this final slide, just in case people are interested in some giveaways of information, so to speak. There's a white paper that is really powerful. Our CTO, Mike Larkin, wrote it along with the help from our product marketing team. This talks about how we go about technically doing it, and in case people want to dive deeper into API interception and how Deepfactor kind of does what it does, it's magic. That's a great white paper. It's available on the website for download. There's an analyst report that we're giving away for us to report about how to build a developer security champions program. So for the heads of engineering, director, VP, CTO type folks in your audience, if they're interested in creating a security culture in their organization, that's a great giveaway for them, so they can download that report for free from the Deepfactor website. And of course, like we discussed, if you'd like a demonstration of the product, please reach out to us on the deepfactor.io page.
All right. So Kiran and Dinesh, thank you so much. It was a great discussion, and thank you very much for taking time again and joining the showcase session with me today. I really appreciate, and all my best wishes for Deepfactor, and thank you again.
Thank you for the opportunity to try.